Here are some more home building education series videos. Let's go ahead and get started with our first one. Let's start this video off by explaining the difference between a dry mix of concrete and a wet mix of concrete. The dry mix would be something that you have not added water to before placing it in the forms, and a wet mix would be something you've added water to and mixed thoroughly before placing it into your forms. And this might sound weird, but this is actually what most of the directions are going to require when building anything out of concrete. However, there is one product I found that allows you to use a dry mixture. You're just simply allowed to pour the dry mix into a footing you're going to use for a fence post. And then after you've added the dry mix, you can thoroughly saturate it with water. Then you're going to get the chemical reaction you need to make the concrete hard. And of course, the reason why I'm making this video is because I found a couple of people on the internet claiming that you could just simply fill the areas in between your form boards with a dry mix of concrete and then wetting it, thoroughly soaking the water into the concrete mix to get the chemical reaction required to make the concrete hard. Now, I don't know if this is going to create something strong enough for your project, but I can tell you that something like this probably won't work for a walkway or a porch, especially if we remove the forms. If you pour the mix and leave the forms, you're going to have a protective barrier around the perimeter. However, once you remove the forms, over time, you could end up cracking a section off of the site that would look something like this. And I'm also not going to suggest that something like this couldn't happen to a mix that you mixed thoroughly before pouring. So to wrap this video up, this is not something I recommend doing. Follow the directions on the concrete bag, and if you're looking for a little more structural strength, add some rebar, and make sure that all of your concrete is poured on a solid, compacted fill material, not loose soil. Here is a follow-up video to a video I made about a week ago about whether or not to use a dry concrete mix instead of a wet concrete mix for your small projects, and are going to try using this dry pour method anyway. Now, the number one problem I see on the internet that has a high probability of failure, whether you're using a dry mix or a wet mix, will be to make the concrete pads at least 3.5 inches thick. Because I've already seen a couple that turned out just fine in the video, but I don't think are going to work in the long run. My next idea would be to raise the form boards up a little bit so that when you're watering your concrete slab, that it will create some type of a container that will allow most of the water to go through the concrete. Because there were a couple of videos that I came across with a concrete slab that wasn't very strong because the water hadn't soaked through it. And if you don't raise the forms, it wouldn't be a bad idea to be careful when you're wetting the concrete to prevent any water from going over the edge of the form boards. Because if water's going over the form boards, there's a good chance that the cement is also going over the form boards, and that's not going to help your finish. Now, if you do want a smoother finish, here's something else that might work. And that would be to screed all of the rocks down to where they're about 1/8 of an inch or 1/4 of an inch lower than the form boards. And then add a layer of Portland cement. The Portland cement should allow you to get a smoother finish or even a nicer broom finish if that's something you're interested in doing. If not, then you could end up with a rougher finish. But again, this might not be a problem for you, especially if you're not planning on finishing the concrete at all with any types of trowels to smooth out the concrete or to round off the edges. Another thing I would definitely suggest doing, I just watched a video where somebody placed a dry mix on top of some wood chips. And over time, these wood chips can decompose and create a void or an area that's underneath your concrete that will no longer be supporting the concrete pad. Make sure that everything you build is on top of a solid foundation or well-compacted soil. I cannot stress this enough, because if you're looking for cracks, soil erosion, tree roots, and uncompacted soil are probably going to be at the top of the list. And of course, why not throw some rebar in there or some type of a wire mesh, something that you're going to use for a wet concrete mix to see if that will help increase the strength. And if you're using a 3.5-inch thick slab, the rebar will be placed somewhere in the center. And you could probably position the rebar after filling up about an inch, inch and a half of dry mix in your forms, and then simply setting the rebar on top of that and then filling it up the rest of the way. And the last thing I want to point out is that most of these pre-mix bags are rated at about 2,000 to 2,500 pounds per square inch. Here's what a square inch looks like, 1 inch by 1 inch. Even if you're only getting 500 pounds per square inch with your dry mix concrete, that might be enough for your project. So keep that in mind also. Now, the last thing I want to say in this video is that I am not 100% convinced that we need to hit something like this with a sledgehammer or drive a truck over it. Because if all you're going to do is put a chicken coop on top of it, and you're never or rarely ever going to step on it, then something like this might work fine. But if you're going to do that, why not just form something up and fill it with gravel and avoid using concrete, whether wet or dry mixed? And for me, I'm not 100% convinced that this is the best way to go for anything, including a small concrete pad, until one of these products tells you in their directions that you're allowed to use the dry pour concrete method and tells you what you can use that method for. Here's another one of those crazy ideas I found on YouTube that I don't think is going to work. And I'm not about to suggest that you can't do this in a different way, but I am about to suggest that I have a few things you need to think about before stacking a bunch of concrete bags on top of each other to create a retaining wall. Now, maybe if you're going to use this for 6 rows or less, 6 rows of concrete bags, maybe you're not going to have a problem. And maybe if you stack them differently, you might not have a problem. But what I'm about to show you here should provide you with everything you need to know about why your large retaining wall built out of concrete bags probably isn't going to work. So let's take a look at a regular retaining wall. It's usually going to be built something like this. It's going to have a large footing with a bunch of rebar in it to prevent the soil or the moisture in the soil from pushing the wall over. And I don't know how you're going to do that just by stacking bags on top of each other. So even if the bags were to hold, you're still going to be dealing with the pressure from the soil behind the bags. And in reality, that's all you need to know for the video. You can stop watching it right here, because I don't think by rearranging the bags somehow you're going to solve this problem. And of course, we can take a look at what the wall's eventually going to look like after the paper wears off, which might not be a big deal, except for the mess that it's going to make on your property. And another problem you could deal with will be tree roots. And trust me, the tree roots will love a wall like this where they can get the roots in between the bags. And then, of course, do what they do best. And that will be to get a little larger over time and speed up the process of destroying a wall like this. So what if we go ahead and put some plastic or some type of a moisture barrier behind the bags of concrete? Will this solve our problem? Probably not. Again, we don't have the large footing like we have over here, or a structurally reinforced solid wall. And even if we can prevent the tree roots or moisture from coming through here, we might not be able to prevent it from going underneath or prevent the massive amount of soil behind the retaining wall from pushing this thing over. And if you do use the plastic, you're going to have to make sure that it is positioned in a way to eliminate all of the moisture from coming through and not just some of it. Because in a situation like this, all of the moisture that settles on the ground in front of the retaining wall can soak up into the lower section. The moisture that's behind the top of the retaining wall can go around it if the moisture barrier isn't tall enough. And I'm not about to suggest that trapping the moisture behind the retaining wall is going to be a good idea either. It could increase the force behind the retaining wall and cause it to fail. And an example of that might look something like this, where we have the wall tilting forward at the top. Another thing most retaining walls will have will be a gravel-lined section behind it and some type of a drainage system that will allow the water that gets trapped behind the retaining wall to be removed from this area. Another thing I would like to point out is that the back of the retaining wall is usually going to have some type of waterproofing material to prevent moisture from absorbing into the retaining wall from this side. And for those of you who want to build this wall out of your concrete bags anyway, and you're thinking, hey, why don't I just install the gravel behind my concrete bags along with my drainage system? And that's probably not going to work. You can remove the water. You can prevent the tree roots from entering into the bags. Along with the water that's going to be trying to go around this thing will usually be enough to destroy a taller wall. And I don't know what the height of that wall would be, but I can tell you that something like this is going to work a lot better than something a little taller. Now, I wouldn't use this method, period. This would not be something I would be using for a straight retaining wall. I've seen this done on curved retaining walls. You might have a better chance at something like that working than you will a straight wall, because I've seen small retaining walls built out of sandbags before that seem to work pretty good until the canvas surrounding the sandbag starts to fall apart. Here's a project I ran across and thought it might be helpful for handrails and concrete stairs. And you can see right here, this right here would be a very weak handrail. It's really nothing stabilizing it. And thought that it might be better if we actually bolt the post onto the outside. All this would require would be some anchor bolts embedded into the concrete to stabilize the posts. And you can see right here that we have a 4x4 post and one anchor bolt. This has a flat washer. You can use round washers, as you'll see later on in the video. Make sure that you hold the post off of the ground. Make sure that it's not touching the concrete. 1/4 of an inch would be fine. And if you do, make sure that you clean it every once in a while. It's common. I've seen people take these off the ground 3/4 of an inch, and eventually you've got a pile of leaves and dirt, and the wood post is starting to rot. So keep that in mind. Wanted to give you an idea what it would look like with the anchor bolt into the concrete. You might need a longer anchor bolt, a 14-inch anchor bolt. Not a 6-inch anchor bolt. I'd go with a little longer one. And then make sure that the anchor bolt, the J-bolt part of it, is turned in. Either turn it in or turn it down, but don't have it going out to the front. It's going to be a little bit stronger if it's the more that this section is embedded into the concrete. And you can do the same thing with a post up here and run them around your stairway. You can use 2 bolts instead of 1. You can always make this one a little longer and full length. And this is just going to provide you with a little more support. Something like this, 1 bolt might do, but 2 bolts might do a little bit better. Here's an example of what it would look like if you had a square washer notched into the post. How you accomplish this, I will leave that up to you, probably with a router. Could do it with a chisel. Here's a round washer on the outside of a post, and here's what the round washer would look like countersunk into the post. And of course you could do this with a larger drill bit. Another thing you might want to do is cut the threads off. I see this a lot. You'll see patios built and the threads are the threaded part of the anchor bolt is sticking out 2 inches. This is going to snag someone's clothes or even hurt somebody. Keep in mind that most building codes do require to see at least 2 of the threads visible on the anchor bolt. So you can't cut the anchor bolt flush with the nut. Give it about 1/4 of an inch or 1/2 inch depending upon what size anchor bolt you're using. I wanted to pull away here and give you an idea of what the post might look like if you're going to be going around a concrete stairway with a landing. You might not be able to put a post in the corner. It might require 2 posts like this. You know, if we were to take the corner here and line it up with this corner here, how would you bolt it to the concrete? So that'd be something to think about. And here's what it would look like on the other side. And here's what the anchor bolts would look like. Just wanted to give you another view of it here. Sometimes it's hard to imagine what the anchor bolts would look like, how they actually work. And there it is. Now, it wouldn't be a bad idea to install some type of a membrane, maybe roofing paper, window flashing paper, or even sheet metal, galvanized metal, in between the post and the concrete. But that would all depend upon how much moisture you actually get in your area. You know, if you live in a wet climate where it rains a lot or you have snow sitting on the ground for a while, you might want something between the post and the concrete to prevent the moisture that gets absorbed in the concrete from absorbing into the wood. You live in a drier climate, the desert, this might not be necessary. Here is another small house that I drew. We have 2 bedrooms, 1 bedroom here, 1 bedroom here, closet, bathroom, and then we have the front entry door here, rear entry door here, window in the kitchen, small kitchen, and room to where you can put a small table here, refrigerator, washer and dryer, living room. And of course, it is 625 square feet, 25 feet wide, 25 feet wide the other way. And next up, let's zoom in on some measurements here to give you an idea what we're dealing with. And I'm just going to go ahead and scroll up here. And the whole reason for this is just to be able to provide you with some measurements in case you're planning on building a project like this. And I do not have any plans available to the public for this, and probably won't in the future. And of course, let's go ahead and zoom out here and head over to our next part of the video, where we will be taking a look at the framing. Now, I'm going to use a 4-12 roof pitch with some trusses here, and I'll talk more about the roof trusses in the next video. So let's go ahead and take a tour around the house here, give you an idea of what the framing is going to look like. Now let's go ahead and remove the building so that we can take a look at the footing placement or location underneath the home. And even though I drew this footing in for future home designs, you will not need this if you're going to have a truss roof, because all of the interior roof loading will be transferred to the perimeter walls, which could save you a few dollars during the construction of your project. And of course, you will need anchor bolts. I didn't draw any anchor bolts in here to fasten the home to the building foundation. Next up, let's go ahead and install our walls. And again, take a look at the front of the house here. Bedroom, closet, bath, bedroom, kitchen area here, washer and dryer, living room. And what I want to do here is what I have done in previous videos, and that will be to break down the wall framing into sections, starting with the front wall and the back wall. Now, the front and the back walls are going to be practically identical except for this window here and this one here. Next up, let's go ahead and head to the back wall, where we're going to have a smaller wall here in the kitchen, and that's going to be to provide us with a little more room for the countertop and its backsplash. And this is definitely something you should spend a little more time on when you're designing it. Do not let that become a mistake when you're building your project. I've seen it happen more than once. And of course, this wall right here, even though it's going to be the same length as the opposite wall, the wall on the other side, it's going to have 3 channels in it for the intersecting walls that will be connecting to it. Next up, let's go ahead and head over to the other side. 2 channels here and no windows. You can always add some windows in if you want to. And even though I don't have any anchor bolts in this video, you will need an anchor bolt within 12 inches of the bottom breaks and within 12 inches of the corners. Another problem that I see often, let's go ahead and install our walls to hide the washer and dryer. And of course, you wouldn't need these walls if you weren't worried about that. So we're going to have a washer and a dryer here and a refrigerator on this side, and then some base cabinets that will wrap around over to here, a sink over here, and then a range over here. I don't think you're going to have enough room for a dishwasher in that kitchen. And then these 2 walls here, again, will be identical. Again, making the job a little easier. Next up, let's go ahead and add a few more walls. Our closet wall here, the wall here to separate the closets from the bathroom. And I don't have my tub backing in here. However, I will try to install that in a future video. Then our closet door and our bedroom door. Let's go ahead and head over to the other side where we have the same thing. Bedroom, closet door. And even though these 2 rooms are small, I don't consider them to be too small. I've seen some designs where the rooms are like 8 foot by 9 foot, where these are going to be a little larger. So the center wall here, and again, this is not a load-bearing wall. However, if we build a conventional roof with a conventional ceiling or roof rafters with ceiling joists, then this will turn into a load-bearing wall, or can turn into a load-bearing wall. I'm not about to suggest you can't use larger lumber to eliminate the concrete footing. However, that might not be cost effective. Again, our framing plate here, 4 foot away from the next break. And of course, all of our windows and doors will have 1 trimmer. You need double trimmers on doors and windows that are 5 foot or larger, kind of a common construction practice. In this video, I'm going to be providing you with the reason why you might see stairs or ladders that are a little steeper than most of the building codes allow. And the reason for that is because right at the beginning of the stair building code section, they provide us with a couple of examples of stairs that are exempt or exemptions. And 2 of those are going to be stairs that lead to an unoccupied attic or crawl space. And of course, these would be areas where people are not going to be living, areas where the stairs are not going to be used that often, therefore reducing the amount of traffic and allowing building designers to build narrower and steeper stairways. And of course, this information came out of the 2024 International Residential Code Book. And then here are the numbers that you can look up to verify the information I'm sharing with you in the video. Here's another question that more than one of our viewers had, so I thought I would make a video. And it has to do with a video I made a few years ago about building a driveway in sections. And I will put a link to that video in the comment area or in the video description box, or both. So in the other video I'm referring to, I had the rebar running through and connecting all of the slabs together, and I would suggest doing that instead of doing it like this, and it will probably make more sense by the time you finish watching the video. So basically, if you're going to cut the rebar into sections and not have it running through, and again, even if it just runs through a foot, and you connect the next rebar to it before you pour the other section, that should work also. So let's just go ahead and run through the sections here. I'm not going to provide a lot of details because, again, I don't recommend doing this. So again, we have the rebar separated, and each individual slab will basically be its own separate unit and will not be connecting to each other. So again, hope this makes sense. The drawings that I've done here. Again, we're not connecting on this side. We're not connecting on this side. And when it's all said and done, you're going to end up with a flat surface, and it's going to look great. It's going to be nice and flat all the way around if you did your job correctly. However, that might not be true in the future. And I really can't tell you how long it's going to last because your driveway could remain flat or within acceptable conditions for a long period of time, decades even. However, if you have a section of the driveway that lifts up or raises for some reason or lowers for some reason on one section, then you're going to end up with a problem like this. However, with the rebar, it can hold the two separate pieces together under minor erosion or lifting problems. I'm not talking about major soil erosion or huge tree roots, because I've seen that actually just crack the concrete around the rebar. And I don't even think we would ever need the rebar if we weren't going to plant anything around the driveway, or if the soil wasn't ever going to get wet, because a lot of times when soil gets wet, it expands. And even concrete can expand when it's wet and contract when it's dry. So when you have soil and concrete getting wet and then drying out and expanding and contracting, then there's a very good chance you're going to end up with some cracks in your driveway, or worse yet, sections underneath the driveway that are either lifting from tree roots or the soil is eroding from water washing it away. And when you finally have enough of that soil washed away, it's only a matter of time before someone drives a heavy vehicle on top of the driveway, breaking a section of the concrete slab or forcing one of the sections down and then lifting the other section up. In this video, we are going to talk about truss uplift. This would be a prefabricated roof truss engineered roofing system that experiences problems from condensation or moisture and different temperature changes. Now, I've never personally had any experiences with this living in Southern California. I don't think you're going to have this type of a problem, but I read up on the internet, did some research on it, and this is actually what I came up with. Whether or not it is the absolute truth, it's hard to tell, but I have had quite a demand for this particular topic. Had a few emails sent to me and figured it was time to do a video, so let's see if this can help you understand what I'm understanding other people are telling us what the problem is. So what happens is that you have a well-insulated attic. Let's just say that you have R30. You got a 9.5, 10-inch insulation in there, and this insulation actually protects the bottom cord of the roof truss. But you can see that the upper cord and all of the webbing is not protected. And what happens is that the bottom cord stays relatively stable, but the top cord starts to absorb moisture from the cold air, and this creates a problem because it causes the wood to expand. And then of course that would be the winter. In the summertime, it reverses the process and goes back to its original shape. So you can kind of see here we've got the insulation, we've got a nice warm bottom cord here, and then as the top cords start to absorb moisture from the air that is circulating through the attic, and I would imagine the webbing is also going to be exposed to this moisture, it actually pulls up, creates a truss uplift. Let's remove the insulation for a better view. And most truss systems are sitting, they're connected to the exterior walls. And the interior walls are going to have a smaller framing plate on them. So here you might have a 2x4 framing plate and a 1x4. But on the exterior, you're going to have two 2x4s. And again, I'm saying the exterior, but you can have a roof truss system that would be attached to the interior somewhere, or could be attached to the interior somewhere, sitting on a full framing plate. But this usually provides a gap in between the framing plates and the bottom of the roof truss. The gap allows the truss to move down when weight is applied to it. So most of the time the truss isn't going to be lifted up. This isn't going to happen except for the temperature change I was just talking about. Usually the truss, after it's framed, is going to settle down. And I have actually seen the roof truss settle down to where it's right on top of the 1x4 framing plate. And I don't know if it's supposed to do that, but I have seen that before. So a lot of times you're going to have a 2x4 framing plate with a 1x4. And this would allow for a 3/4 inch gap here. You are not going to have that on the exterior walls where the roof truss is connected directly to the plate. Here we would have two framing plates. Reason why I'm explaining this is because of for those of you who have a truss uplift problem and the drywall is cracking in the corners, and you can see where the drywall is lifting up. I just don't want you to freak out when you get into the attic and you say, hey, wait a minute, the truss is really lifted up here. That's not normally going to be the case. So hopefully now you understand that. So, and usually you're going to have truss clips attached to the trusses and to the framing plates. They might be 24 inches on center. They might be 4 foot on center, might be 16 inches on center. So here's the drywall. Drywall is usually going to be installed first. This will attach to the ceiling, and then the drywall to the wall will be applied after that. And of course, the reason why I'm telling you this is to give you an idea of what you're actually looking at when you do see a gap here. So the drywall's attached here, usually going to have paper tape or fiberglass tape, which of course will rip when enough pressure is applied to it. Seen that plenty of times. And then you will have a gap here. Here's a good example of what it would look like after the truss lifted up. Your drywall will separate and you will have a gap in between the top corners. And of course, this is probably the reason why you're watching this video. I want to provide you with one more example for those of you who might not understand what I'm referring to. A regular truss that is not having any problems at all is going to have a relatively straight bottom chord. A truss that is going to be experiencing uplift is going to have a bowed or curved chord as the lumber expands. So according to the experts, or the information I've gathered off the internet, I should say, the lumber above the insulated area, the bottom chord is going to be insulated. The webbing and the upper chord might not be insulated. And if this is the case, these are the areas that are going to absorb moisture, causing the lumber to expand. And then, of course, causing the truss eventually to lift up. So relatively straight bottom chord on the truss for the ceilings would be a normal truss under normal conditions. When there's a lot of moisture in the air, you are going to have a truss that, I should say you could have a truss that would bow or lift up in the center. So I don't understand everything about this, and I'm not going to pretend that I do. But that is from the information I gathered on the internet. It doesn't make 100% sense to me, but it is a problem, and it is happening, has been happening. And I will put a link here or at the end of the video to provide you with a few ideas on how you can fix it if it's already happened, or prevent it from happening if you are building a new home. In this video, we will talk about truss uplift repair ideas, provide you with a few solutions for damage that has already happened, as well as new construction. So for those of you who aren't familiar, I will put a link here. You can go watch the previous video and then come back and watch this one, or watch this one and then go back and watch that one. So remember that the truss uplift problems usually are caused by the trusses expanding and contracting. And then, of course, this would be raising the ceiling, then lowering it during different parts of the year. The first suggestion I have would be to install some crown molding. And of course, this would need to be attached to the roof ceiling, the truss, and not the wall. You're going to need a little gap here. If you just simply install the crown molding tight, when it moves, it could actually scratch or damage the wall as it moves up and down over the course of time. So again, this will attach to the roof truss or to the ceiling. You could always install a block of wood. It doesn't have to be something fancy. It could be a small, something 3/4 of an inch by 3/4 of an inch, just something to cover the gap. I do not recommend filling the gap with any fillers, caulking, plaster, or anything, because when this comes back down, it's going to put a lot of pressure on this and probably squeeze the caulking out or do some more damage to the corner here. Here's an idea you can use for new construction, and that would be to fasten a piece of metal, some type of L metal, to the walls, the interior walls, and make sure that it is tight to the bottom of the truss. And of course, you're going to need to make sure that the roof is loaded with all of the roofing materials. All of the weight that is going to be installed on the engineered trusses is installed, and that they have settled to where they are going to be in their proper position. Now, thinking about this and the way that this is going to be used, it might not work in small spaces like closets very well. So this might be an idea that'll work in an open room, but might not work very well in a closet. You might need to try something else. You can see here that it is tight to the bottom of the cord. Next, you will install drywall, but you're not going to nail a section of the drywall. And whether you got to go back 12 inches or 16 inches, that would be difficult for me to say. You will attach the drywall, but it needs to be able to move so that when the roof lifts, that it can actually flex here a little bit. And then after, and this is how it's going to look before it moves, to give you an idea. So you are going to have the metal here, and the metal will actually put pressure on the top of the drywall so that when it raises, the drywall will move and the metal will prevent it from going up, and then you will not end up with a crack in the drywall. Hopefully, I say. But again, the nails are going to need to be spaced away, and the building department might not approve something like this also. So you might want to check with them before you do anything. And again, the metal will go all the way across. And that is a popular idea. I actually found this on the internet. The only ideas I will take credit for will be the next ones. Here's my simple and easy idea. That would be a wallpaper border. They come in different sizes. I think between 4 inches and 12 inches, something like that, and can be installed very quickly and easily and inexpensive. But whether or not you would want a border in your rooms or not, that would be up to you. If you were to install it when the truss was lifting up, you just simply put it tight to the ceiling, and then when the truss settles back down, it's just going to bend the paper a little bit. Over time, you might need to replace the border, but again, cheap and easy. Another idea, and I don't know if this is actually going to work, if it's feasible, I haven't heard anybody mention anything about this, that would be to insulate the top cords. That would still expose all of the webbing boards here. And this could actually be a problem. As they absorb moisture, they could put pressure on these areas. So I don't know if this would work. If you have just a little bit of truss uplift, this might just be enough to solve your problem. Here's a question that I have seen numerous times on my fence videos and thought now would be a good time to set the record straight, or at least provide you with my opinion on it. And the viewers want to know why they shouldn't wrap the bottom of their fence post. One of the reasons is that the fence post itself, unless it's treated somehow to where it won't absorb moisture, any moisture that absorbs into the wood can work its way down, and any moisture that works its way down into a sealed container will remain trapped, or I should say could remain trapped, unless it's going to get pulled back up somehow. Should you leave the bottom of the container or just wrap the sides of it? This might be a better option. Again, I'm not a big fan of either one of these. This would allow moisture to drain into the soil, but it would also allow any moisture in the soil to absorb into the wood. So not a big fan, like I said, of either one. Here's the container trapping water. This one doesn't. If there's a hole on the bottom, like I said, you might not have a problem with moisture, but again, you might as water absorbs into the wood post from the bottom. If you have lower water tables, this might not be a problem. You could actually put gravel at the bottom of it. However, if you have water levels that are a little higher than the gravel or seeping into the gravel, this gravel is going to allow the moisture in the soil to, or I should say it will, this is the easiest path. The water will actually drain out of the soil and into the gravel and remain in the gravel longer than it will in the soil. And it's kind of like a septic tank in reverse. You have septic lines that are supposed to drain water from the sewage into the soil. Now, if the soil ever fills up with water, you ever get a situation like this, the septic lines are going to fill up with water also. Something they don't talk about very much, but hopefully that's something that doesn't happen. So the same situation here. So let's say if you wanted to solve your problem by opening up the bottom of the post for drainage by putting gravel on the bottom, it might be a good idea in areas where the water levels aren't high or in areas where the water isn't there on a regular basis. Now, another problem you could have, and this is a problem with all fence posts, but again, you're looking for avenues to where water is going to get into the in between the protective membrane and the wood, and this of course could get in through small little cracks. And if the soil level ever raises or debris starts to accumulate around the bottom of the wood post, this is supposed to be debris, by the way, then you could provide an avenue for the water to absorb into the wood faster and work its way down. Sprinklers, oh, they're a nightmare. Could you imagine watering something like this on a regular basis? Yes, the container is going to fill up faster. Plants, had to throw this one in here. Plants are obviously, not all plants, but some plants that are in the shade, or some plants actually provide shaded areas. Shaded areas could retain moisture for long periods of time, and in some cases all the time. You could have moisture on a wood fence post like this for a long period of time. So anyway, that is it for this video. Do I recommend doing something like this? I'm not entirely convinced that this is our best option. If I was going to go through the trouble of doing something like this in a dry area like the desert, what would be the point? It's not going to, you're not going to have moisture in the soil. You know, in an area that's not going to receive a lot of water, what would be the point again? You know, it's not going to be doing anything. Areas where you do have a lot of water, I think it's going to create a bigger problem. And again, we can't forget about some of the problems that are going to allow moisture to either absorb into the wood and work its way down, go through the cracks and work its way down. Anything like that, I think, could create a problem. In this one right here, again, it could absorb moisture from the bottom just as well as it could drain moisture away from it through the bottom. And that will be it for this video. In this video, I am going to provide you with something that you need to think about when designing a home addition or even a new house. When you are worried about the position of the ridge being higher or lower when it connects to another building. And it's this simple. A shorter span will have a lower ridge height, and a wider span will have a taller ridge height, as long as you are going to use the same roof pitch for each section of the house that is going to intersect into the other. And in our example, we are going to be using a 5 and 12 roof pitch, along with a 10-foot wide building, a 15-foot wide building, and a 20-foot wide building. And if we take the 10-foot wide building and then intersect it into the 15-foot wide building, we are going to end up with a roof that will look something like this, and a ridge that will be lower than the wider section of the building. And then we're going to have the opposite effect if I take the wider span and intersect it into a shorter span. So again, 15-foot wide on this section, 20-foot wide on this section, and then we're going to have a ridge that will look something like this. And this is something that messes up a lot of people. And if this isn't making sense, I went ahead and changed the color of this section of the building, because this roof plane is going to continue flat or straight up to the roof ridge as this section of the roof intersects into this part of the building. So not too difficult. The shorter the span, the lower the ridge. The wider the span, the higher the ridge. Here is another helpful video for those of you who are not interested in wasting any more lumber than necessary when building a deck. And in this video, I'm going to provide you with 3 examples of how you can build a deck without any wasted lumber and without cutting one single board. And by the time you're done watching the video, you're going to realize that you can apply this method to a variety of different decks that can be built in 2-foot increments. For example, an 8-foot by 8-foot deck, or even a 10-foot by 12-foot deck, or a 12-foot by 16-foot deck. However, you're going to have to break out the saw if you're going to build your decks in 1-foot increments. So let's go ahead and take a look at the deck here. We're going to be using bridging here. However, you won't need to use bridging if you want to break the saw out and cut some blocks. However, if you do that, then it's going to defeat the purpose of this video. And don't worry about doing that. If it's going to be easier for you to use blocks than the bridging, then I say go for it. But I'm using the bridging because I'm providing you with a deck that can be built without any cuts. And of course, the bridging is going to be installed from the bottom and the top. And you will need to purchase the correct bridging, which might require you to purchase a certain size joist. Again, something you will need to think about during the design phase. And for this project to work, the decking and these beams will need to be the same size. However, if I want to change the length of the deck, then I can do that by installing different sized joist. For example, maybe 8 10-footers or 14 or 16-footers to provide us with our 12-foot by 12-foot 2 1/8 inches. And you're probably wondering, how did we end up with this measurement here? And that's because we lined our first decking board up with the edge of the joist, and then we left an 1/8 of an inch gap in between each one of the decking boards, only to find out that when we got over to here that this last board is going to be sticking out a little further. So to fix this, all we need to do is nail another board, maybe a 2x4, onto the end of the joist, or a piece of decking like I have here, depending upon what lumber prices are at the time of when you're building your deck. Or if you want to break out your saw, you can rip this last decking board. I will leave that up to you. And that's why we get a 12-foot by 12-foot 2 1/8 inch deck this way. Now for our second example, I'm going to reduce the length of the deck. And again, this isn't going to be difficult to do. I'm going to use 8-foot long joist. And to provide you with another example, I'm going to run the bracing down the center, because this might provide us with enough structural support to prevent the joist from leaning and save you a few dollars on your project. Now in this example, I'm not going to have the same problem with the decking. If I start at the front and then have an 1/8 of an inch gap in between each one of the decking boards, I'm going to end up with a situation like this where the joist is going to be a little bit longer than the decking. However, if you don't like that, I'll provide you with an example of how you can fix that also. Again, without using a saw to cut any lumber. And since we are a 1/2 inch short, we're going to end up with a shorter deck. Instead of our 8-foot by 12-foot, we're going to be a 1/2 inch short. And in our last example, we are going to have a longer deck, which again is just going to require us to have longer support beams and possibly another concrete footing in the center if the span of our beam isn't going to work. However, we could always increase the size of the beam to eliminate the footings, and that's going to be something to consider when you're designing the project. Now in this one here, I also moved the bridging closer to the end to provide you with another example of how that can be done. And it wouldn't be a bad idea to install the bridging near the ends, except if you have a situation where you have a span greater than 10 feet, then you will also need to run another row down the middle. And of course you can see here where the 16-foot decking is going to match with the 16-foot long beams. And then I'm going to go ahead and space the decking a 32nd of an inch wider on each joint so that I can get rid of the 1/2 inch gap that I had here. And even though I'm suggesting this, I'm not saying that you can do it, especially if you are using lumber that might not be completely dry yet and is going to shrink and leave you with a 1/4 of an inch or a 3/8 of an inch gap that could create a safety problem. And as always, check with your local building authorities to verify the information in all of the videos you watch on YouTube. And of course, now you have another tool for your construction toolbox. And I would suggest to put a little thought into your design and the building process to maximize the square footage and reduce the amount of waste for your next deck building project. Here's something that might be helpful for anyone who is trying to cut a tread, and this might work for risers also, that needs to fit in between two walls. And they actually make a jig that you can purchase. And there are a couple of other videos that I found showing how you can make your own jig to cut these treads. However, one of our viewers suggested that what if you're only going to be doing a few steps and you don't feel like making your own jig or purchasing one? And if that's the case, something like this might work just fine, but you are going to need a couple of clamps. However, these clamps could also be replaced by screws. If you could run a screw down through these two boards, you're going to need at least 4 screws. And that would be one over here, one around here, and one around here, if you're not interested in purchasing the clamps. And you can see here where we extended a piece of scrap wood. You're going to need something like this and a straight board. However, these boards don't need to be as long as I have them. You could always make them a little shorter. And of course, the front board is going to go up against the tread or the face of the tread. And this really won't matter if the tread has a nosing on it or doesn't. And I would strongly suggest for anyone who's going to do something like this to cut all your scrap pieces and do one step and make sure that you understand the process of what you're actually doing. And you can see here where everything is square. However, if you have a situation where the wall is angled just a little bit, then you're going to hold this board here tight up against the wall. And don't worry about what the back looks like, because everything you're going to be focusing on will be based off of the front, your guide board that is under these two pieces. And let's go ahead and take a look at the bottom to get a better idea. The guide board is straight and tight to the front of the tread, and you have clamped everything together. Then you can go ahead and move it over and then place the guide template on top of your tread materials and tight up against the front of the tread or the front of the lumber there. And I'm also providing you with two different examples. This was the first jig that we created in the video, and this one here was the second one. And you can see where it's nice and tight. And I would imagine by now you're starting to get a pretty good idea what we're doing. However, if you don't, and this isn't making any sense, then I'm not about to suggest that you leave any questions in the comment area and you're going to be doing the work, then maybe purchase one of the jigs. And of course, you will need to draw a line here. You can see where the line is going to be drawn here. And also pay attention to any gaps that you might have when you have this board up against the wall. Because if there's a gap over here, a gap over here, or a gap in the center, then you will need to make more adjustments before cutting the tread. If it is not going to be a straight line, then do not cut a straight line. Kind of curve it if possible. And of course, if that is a problem, then you might need to make a few different pieces. For example, you might need to put a small curve on one end. And that's going to work out good with your scrap pieces of wood. However, that's not going to work good with a stair jig that you might have purchased for $100 or $200. Also providing you with another example of a problem you could run into. So you can see here where this part of the step is a little more square at a 90-degree angle, where this side over here is not square. However, it is shaped to fit in the wall. And it's going to look pretty good if you don't have any deformed sections of the wall. So after you have cut it, you can go ahead and put it into place. And if everything looks good, then you have done your job without spending a lot of extra money on a fancy stair jig that you're only going to use once. Bathroom remodeling and more videos. Yes, you're even going to see a strange creature in one of these videos. In this video, we will take a look at a couple of methods that you can use if you need to move the drain pipe for your toilet a few feet, or in some cases, even up to 12 feet away from the vent that it is connecting to. And I'm not about to suggest that this is going to work every single time, because it's going to depend a lot upon the drainage for the pipe. Are you going to be able to get the slope required by your local building department? And that might be anywhere between 1/4 of an inch per foot or 1/8 of an inch per foot. So the first thing you're going to want to do before you cut any of the concrete will be to look down the drain and see if you have a little bit of drop here. And you could do that by simply sticking a measuring tape down the drain. And if you have about 10 inches, then you're probably going to be okay. And that measurement would basically be down to about here somewhere. If you just stuck a ruler or a tape measure straight down, you'd kind of hit something like this. I'm not suggesting that you take the tape measure and stick it all the way down the drain, because in reality, this is the measurement that's going to matter the most. And if you can see that from the inside of the drain, then that's the measurement you're going to need. For example, if this is 3 inches and I need 1/4 of an inch per foot slope, then there's a good chance I'd be able to move this about 8 feet, maybe even 10 feet or 12 feet. And after you've figured that out, then you can go ahead and take out some of the concrete slab and the soil. And then you can cut the pipe at the desired location. I would not suggest cutting this pipe at all until you have figured out whether or not the plumbing layout you're going to use is going to work or not. Because if it isn't, you can simply fill this back up with fill material and re-pour the concrete. Because the last thing you want to do is cut this pipe in the wrong spot, only to realize that the mistake you made is now going to require you to remove a larger section of the plumbing. So again, let's put a little thought into this before you get carried away. Now, in our first example, we're simply going to use a coupling and then 90 off of that coupling and come over a few feet. And for something like this, we shouldn't have a problem. This is something that most building codes are going to allow because you're only moving it a few feet. However, once you start moving the toilet more than 5 or 6 feet, then you could actually end up with some building code issues. Another method you could use would be to come off of the coupling there and then 90 over like we did on the other side over here. And again, with something like this, I don't think we've went more than 5 feet yet. And of course, this would work if you went in the other direction. Or you could always install a 45-degree fitting or a 22.5-degree fitting to end up with something like this. And this is actually something most plumbers or building departments are going to appreciate because you've just reduced the amount of this by 45 degrees if I've done my math correctly. And if you're going to do something like this, then the coupling here can move a little farther away. Now, the one thing I like about moving the coupling a little farther away than having it right up against the other coupling is that it will give you some room for error. Let's just say that I move the coupling over here and I glue all of my piping together and I find out that I'm an inch off. And if that's the case, I could either cut it right here, cut it somewhere over here, and add another coupling. But I really wouldn't be able to do that if I had to cut it right here. And I hope that makes sense because that is definitely another thing you don't want to run into. You don't want to end up creating a problem to where you're going to need to remove this fitting here. And I couldn't end the video without suggesting that this is going to work for this particular design. However, if you have a different design, I'm planning on creating a variety of different videos on how you can relocate certain plumbing fixtures, bathtubs, toilets, sinks, and showers in a variety of different situations. In this video, I want to try and provide you with a better understanding of why a toilet that is moving or rocking back and forth while you're using it could actually create a water leak. And I'm guessing that this is probably the biggest problem that would create a water leak. Or should I say, in other words, I don't remember ever coming to a house where there was a water leak and the toilet was firmly secured to the floor and not moving. So if your toilet is moving from side to side, then there's a good chance that it is creating problems for the wax ring if you're using a wax ring. And usually what it does when the toilet rocks from side to side is that it will eventually squash the wax ring or deform it in a way that water can be allowed to leak from any area around it that is no longer sealed. And to make a little more sense out of it, for those of you who still might be confused, let's go ahead and take a look at how the toilet can move, along with a few things that you might be able to do to stop the toilet from moving and hopefully eliminate your water leak. So let's go ahead and start with the plumbing flange for the toilet that is placed in the proper location along with the bolts and the wax ring that would be creating a nice positive seal, along with the toilet sitting firmly on top of the flooring and providing us with a toilet that isn't going to move very much if it's going to move at all. Now, the first thing on the list you need to try when you have a toilet that is moving will be to tighten the bolts. And I would imagine about half the time you're not going to be able to move the nuts at all because of the corrosion or rust that is going to be around them. And if this is the case, you will need to use some type of a saw, like a Sawzall, and try to cut in between the top of the washer and the bottom of the nut to prevent damaging the top of the toilet or the porcelain. And if you can't do that, then you might need to just give it a shot and cut it anyway, unless you're planning on replacing the toilet. If you're planning on replacing the toilet, you can simply grab a hammer and break the area around the nut and the washer, and then remove the toilet, and then hopefully remove and replace the bolts. And this is actually one of the biggest reasons why toilets move, is because the bolts can no longer be tightened. Next up on the list, and this isn't that common, However, it is a possibility you need to be aware of is that the plumbing pipe might not be firmly secured, even though the toilet is firmly secured to the flange and allowing the pipe to move back and forth while you're using the toilet. Next up on the list, another problem could be that the toilet flange itself was not installed correctly and is sitting a little higher than it should be, allowing for a gap on either one side or both sides, allowing the toilet to move in either direction. And again, in some cases, you might be able to fix this by tightening the bolts. However, that might not work if you have already squashed the wax ring and can no longer tighten the bolts. And if the bolts are loose and allowing the toilet to rock on top of the flange, then this is usually what happens when the toilet moves from one side to the other side, allowing one side of the wax ring to get squashed while creating a gap at the other end that could allow water to escape while the toilet is being flushed or leaking. And keep in mind that if the toilet is only rocking to one side, that only one side is going to get squashed or deformed. However, that's not going to be the case if it moves to the left. It's going to squash the wax ring and allow a gap on the other side. And then when it rocks back to the other side, it's going to allow the gap on this side while squashing and continuing to deform the wax ring to where it no longer has a positive seal. Now, if you do have this problem, you could always install some type of a shim underneath the toilet, and you're probably going to have to install the shims on both sides. And make sure that you use some type of a material that is not going to decompose. For example, wood might not be the best choice. However, I wouldn't rule it out as long as you no longer have any water leaking around the base of the toilet. However, tile or cement-based products or even metal might work a little better as a means to stabilize the toilet. And even though in a situation to where the toilet flange is a little too low, you're usually not going to end up with a toilet that is going to move or rock back and forth. However, you could end up with a gap in between the top of the wax ring and the bottom of the toilet that would allow water to seep out of this area and onto the flooring. And most of the time, to fix something like this, all you need to do is add another wax ring. And I do have another video at the website if you think you have that problem. And for our last example, I will provide you with something that I just recently dealt with. And this would be something that could happen in a wood-framed floor and a concrete foundation. And that would be a situation where they used some type of a bolt that either screwed into the wood framing or somehow use some type of a lead filler that would allow you to install some type of a screw into it in the concrete that might no longer be working and allowing the toilet to move. And again, in some cases, all you need is one loose bolt. And normally what happens in this situation is that the bolt is no longer gripping to the lead, or the lead is no longer gripping to the concrete. And something like this will allow either the bolt or the sleeve to separate and raise out of either the concrete or the lumber used for the framing of the foundation. And something like this might actually require you to install a toilet flange or even contact a professional plumber to repair. And that's actually how I solved my problem, by removing the plumbing and replacing it. However, this isn't going to be an option for your average do-it-yourselfer. Here is something that started with a toilet leak. You can see the water here at the base of the toilet, which forced me to remove the toilet and replace the wax ring. And for those of you who might not be familiar with leaking toilets, at the bottom, and you can see here that this is the flooring, and we have the bolts that connect the toilet to the floor. And if you can see here, the wax is flat. It has been squashed to create a nice seal. That is not the case over here. And I could have just added another toilet ring to this. However, I didn't like the fact that there was a discoloration here, something that might have looked like it was mold. And even though you can't see it now, here's the creature that I found. It was a little lizard in here. And even though I have found a variety of different things in the plumbing drain and in the toilet, for example, children's toys, and even an aluminum can one time, I have never found anything that was moving. And for those of you who might have a difficult time seeing the little guy, he's right here. He's got 2 eyes, 2 front legs. And I went ahead and cut out a view of the little guy there for those of you who might not be able to see him where he's at because of the discoloration, because the little guy blends in with the background here. And yes, there is a happy ending to the story. I removed him and relocated him out to the backyard and cleaned all of this up and fixed the water leak. And for those of you who might not be interested with the little creature here, you're more interested in the toilet leaking repairs, I will put some links to those in the video description area.